So it's clear that standard deviation, it's a broad measure of the difference between the elements in the data set, but it's not an accurate way to determine which of those elements it's corrupt, bad, or somehow out of range. So in order to do that, we can still use standard deviation, but we need to devise an algorithm. And this is what for loops and arrays are really good for. So in this case, I would go ahead and do something that's called a quorum algorithm, where you can determine by running the standard deviation on all the elements of the array except for one of them at a time. You can then see if you get the 17 or if you get the 1.6, and then once you get 1.6, 1.6, or close to 1 and 2, for most standard deviations calculated without one element, and then you calculate it without the last element, and then that standard deviation is 17, then you've found yourself the target. So in order to do that, we are going to use loops and a couple other arrays to work with. So the first thing we need to do is create another array. We'll create an array called working list, and working list is basically going to be our holding array. It's an array that we're going to use in our calculation. Next array we're going to have, it's going to be a array of standard deviations. So all of these arrays are going to derive off the outsider temperatures array. And so they all have to have the same number of elements. So this is all pretty straightforward. These standard deviations are basically, it's an array, it's a list that it's going to hold the standard deviation calculated for all the elements in the array except for one of them. So in the first iteration, we're gonna say, okay, give me a standard deviation with OA temps 2 through 10 and leave 1 outside, and then that one standard deviation value calculated off of these elements, it's gonna get stored in element number 1 of the standard deviations array. Then we'll do, okay, another standard deviation with all the elements except for 2. We'll single 2 out, and so on. So let's see how that would work out. So this that I'm doing here is nesting a for loop inside another for loop. When you nest, I recommend that you indent the code inside the initial construct or the root construct. So this would be your root level construct or programming scope, because bear in mind, all of this is in programming there's something called scope. So in programming, variables have a scope. This code is inside the local scope of this for loop. All these variables, however, are within the scope of the whole program because they got declared inside the program. Had they been declared, if this language allowed, inside the for loop, for example, then it could not be referenced anywhere outside the for loop. Now, this is what happens when we create functions. None of the variables declared inside the function are accessible in the program that calls the function unless those had been declared as arguments in that function. In this case, the program that calls the function can pass values into those arguments. So every time we nest programming constructs, we must we should, for good measure, close open and close the program and then write your code inside. Because if we were to do 6, 7 for loops inside each other, for example, or if-else statements inside each other, and then we had to figure out the next or the end if for every one of those nested statements, we could get confusing and then you'd get errors. So it's best that as you make it, as you build the code, you open and close your scopes of programming before you start adding more code inside it. So here we've got a few more variables that we've not yet declared. So let's go ahead and do that. We've got I, which is another placeholder variable to run our loops. Then we've got W, which we've already declared, and now N just popped up, which is, these are all placeholder variables. And now we are here. We're going to use I to loop through our outermost for loop. And inside this loop, we're basically going to loop through the OA temps array. Inside this for loop, we've got a sort of like a cleaner for loop. Again, I mentioned our working list array is a placeholder array for algorithm use only. And so every time we use it, we've got to clean it out. We've got to flush out any old values from the algorithm calculating prior times. So this is this first loop that loops through this working list, and it zeroes every element out. Then we make sure that the placeholder variable that we used itself clears out to 0 as well. Then we run another loop, which is the loop that actually does something. using the n placeholder variable. Now this n placeholder variable is taking the place, as you can see, of every element in the working list array. And that is how you use these placeholders, is you use it in place of any of the elements of the array. So as the loop loops through 1 through 10, it assigns the current element is iterating through to n. So then you can use n to call out on other arrays that may somehow map into this array. So we're doing that with working list and OA temps. So this is basically saying if we are right now on array number 1 and I is also on array element number 1, I'm sorry, I should have said array element number 1, then this would be false because this is looking for I to be different than n. So essentially the first time that we run this will be false because n and I will have the same element, which will be 1. And in that case, we do not pass that value over from OA temps at element 1 to working list in element 1. And so we exit the for loop when we're done. Well, obviously when we get to element number 2 and the I, the outermost loop, is still on 1, because again this is gonna inside this guy is gonna, while this guy is still iterating through element 1, this guy is gonna iterate 1 through 10. In one single iteration of the outer loop, the inner loop is gonna iterate 10 times. And so this will run the first time, it will examine as false, we will not pass OA temp element number 1 to working list element number 1, but then when this runs again and I is still 1 but n is 2, then this will be true, and then the first element of working list will be element number 2 of OA temps, and it'll continue to be true for all the rest of them. And then by the time we get here, our working list is gonna have all of these elements in it, and then we run a standard deviation with only those, excluding element number 1. And then that standard deviation gets passed to element I, element number 1 in this case, of the standard deviations array, and we start filling the standard deviations array with deviations that exclude one single element at a time. Let's see how that how that plays out as we debug.